All right, these are the notes for lesson 4.1 and 4.2. We're going to talk about ratios, proportions, and similar figures. A ratio is a comparison of two numbers by division, usually written as a fraction. Okay. A rate is a ratio, like A over B, the fraction A over B, where A and B have different units of measure. For example, 100 meters in 60 seconds. Okay. A unit rate is a rate that has a 1 in the denominator. For example, miles per hour. So 250, so our first example says, write 250 miles over 5 hours as a unit rate. So 250 miles in 5 hours, and I'm going to write it as a unit rate. So basically I'm going to divide the top and the bottom both by 5, the bottom number. Okay, so 50 miles in 1 hour, and we read this as 50 miles per hour. Okay? All right. A proportion is an equation that states two ratios are equal. Proportion is an equation that states two ratios are equal. So I have ratio A over B equals C over D. In order to solve a proportion, hopefully you guys get this, we cross multiply. Most of you remember that. Okay? So in our example, I have 45 over X equals 75 over 12. I'm solving for X. All right, so I'm going to cross multiply. That's the first thing that I'm going to do. 75 times X, 75X, 45 times 12 is 540, and then I divide both sides by 75. 540 divided by 75 is 7.2. So X equals 7.2. Okay. Conversion factors let us change units in a rate. For example, the fastest recorded speed of the eastern gray kangaroo is 40 miles per hour. I want to change that speed to feet per second. So I need to change my miles to feet, and I need to change my hours to seconds. We do that by using conversion factors, or doing what's called an analysis, unit analysis. So let's talk about this. The first thing I need to remember from, hopefully you guys remember this from pre-algebra, that whatever units I'm trying to cross out, if they're on the bottom, I put them on the top because we're multiplying, so that way I can cross reduce. So 1 hour is equivalent to 60 minutes. That's a conversion factor right here. Okay. I also have that 1 minute equals 60 seconds. That's a conversion factor. And then feet per mile. Let's see. 5,280 feet equal 1 mile. Last year I used to tell you guys all the time, 5 tomatoes, 5280, 5 tomatoes. Let's cross off the units that we're going to cancel out. I'm going to cancel out hours, minutes, and miles. And then I just multiply straight across. So I end up with 40 times 5,280, which equals 211,200 over 60 times 60, which is 3,600, and I need to divide that. So 2,100, sorry, 21, 2, So 211,200 divided by 3,600 equals 58.6 feet per second. The 6 is repeating. 58.6 feet per second. If I wanted to remember that 0.6 repeating is the same thing as 2/3, I could write it like that. 58 2/3 feet per second. Okay? Sometimes we use proportions to predict. Choice of entrees and the number of people. So this table here talks about the choice of entrees available and the number of people. So it says that 48 people chose chicken Kiev, 56 people chose prime rib, and 31 people chose grilled salmon. So the first thing I need to figure out is how many total people were interviewed, and that's a total of 135 people. The next thing that I need to do is, says that 125, that should actually say 135. 135 people were surveyed for entree selections at a wedding. Use the table to predict the proportions of prime rib needed to serve 1,500 guests. So let's see, I need to know the number of portions of prime rib. So I have 56 out of 135, and that needs to be proportionate to a certain number of prime rib out of 1,500. So again, I'm just going to cross multiply. So that's 135x equals 56 times 1,500 is 84,000. I'm going to divide both sides by 135. And I get 622.2. We don't want to run out, so we're going to say about 623 portions of prime rib. Okay, so we could use that to predict. So proportions sometimes help us predict. Similar shapes. Similar shapes have the same shape, but not necessarily the same size. So similar shapes have the same shape, but not necessarily the same size. This little curly tilde means is similar to. In similar polygons, the corresponding angles are congruent and the corresponding sides are proportional. So I want us to find all the missing links. So let's look at the information I have. 9 is proportional to 6. So 9 is to 6 as x is to 8. And again, I can solve that by cross multiplying. 6x equals 72, so x equals 12. So I know that this is 12. How can I solve for y and z? I don't have either measurement. Well, fortunately for us, these are right triangles, and I did that on purpose because I wanted to remind you of the Pythagorean theorem. 9 squared plus 12 squared equals c squared. And these are actually Pythagorean triples, 3, 4, 5, or a multiple thereof. 81 plus 144 equals c squared. 225 equals c squared. Take the square root of both sides, so 15 equals c. So this is actually 15 meters right here, and this measurement is going to be 10 meters. Okay? All right, a tree casts a shadow that is 9 feet long. So here's my tree casting a shadow. It's 9 feet long. Jeff is 6 feet tall and casts a shadow that is 4.5 feet long. How tall is the tree? So if I were to take Jeff's height compared to his shadow is proportionate to the tree's height compared to the tree's shadow, and I cross multiply, I have that 54 equals 4.5x. When I divide both sides by 4.5, find that 12 equals the height of the tree. So the tree is 12 feet tall. Lastly, we use similar figures as scales. We talk about scaling. So I have an example here, the scale of a map. The scale tells us when we look at a map how many inches or centimeters represents the total distance. So the scale of this map is 1 inch of my map is equivalent to 50 kilometers. So 1 inch is equivalent to 50 kilometers. The map distance from Gary to Indianapolis is 4.5 inches. How far is the actual distance? How many kilometers is that really? So again, I have a proportion. So I have 1x equals 50 times 4.5. So 225 kilometers. So the distance from Gary, Indiana to Indianapolis is about 225 kilometers. Now if you Google it, Google will tell you that it's actually 226 kilometers, but we were close. Okay, so this is your homework. You have 26 problems. I told you that you were going to have homework over the weekend. We haven't had it at all this week. Page 185, there are the numbers, and then page 191. So a total of 26 problems. Remember that this is 2 lessons. I will upload your textbook pages onto My Big Campus as well. Good luck.